Okay. Hello, everyone again. I'm Victor Kumbol, and I'll be sharing my experience about DIY Labware, promoting open science hardware in Ghana. Okay, yeah. So, just an overview of the presentation. I'll talk about myself, how I got involved into open hardware, the whole idea about DIY Labware and what we are trying to achieve, the strategy we are using, a bit about the workshop which we had last month, and some of the outcomes and insights from the workshop, and the things that we are looking to do next after this workshop. Okay, so I'm a pharmacist, and I talked briefly in a private electronics stuff like that to build projects to actually solve like real life problems in Ghana. So I've been involved in that like since 2014. And I mean, in terms of research, I'm interested in neuroscience and pharmacology, and then just recently opened Labware. So my journey into open Labware really began with the Trend Advanced Open Labware workshop, which was last year in April. So I mean, it's really been like a very sharp learning curve for me. And even though I was involved in like electronics and Arduino, I hadn't really used it in like building open Labware. It was during the Trend workshop in Cape Town that was my first like experience to open Labware, and that's why I got to meet Andre. And after the workshop, my team and I, we were able to publish the equipment we built, which was really exciting, because we're all from like biomedical backgrounds, and it was really exciting to have us like publish like an equipment. And then afterwards, I got involved in the Open Leaders, Mozilla Open Leaders program, to learn more about leading open projects since I was, and that was like my entry into open projects and the whole idea of like working open. So I got to the Mozilla Open Leaders program, and then I got a grant, the mini science grants to organize this workshop in Ghana, which we just had last month. So the whole mission of the DIY Labware project is we're working with scientists and developers in Ghana to build an open hardware community locally, and the idea is to empower scientists to develop their own lab equipment. And so the goals, firstly, to increase awareness about open hardware, because a lot of people don't really know about open science hardware, and like you can even build your own lab equipment. So creating awareness, and then also training. So training faculty and students to build their own equipment. And I mean, in the process, document and build some of these equipment. And finally, which is like the main goal, is to sort of create a community, a local community here where people can share resources and help each other to build their own lab equipment. And so the strategy has been, I mean, with training workshops like the very first one we had last month, to give people the opportunity to learn the skills hands-on, and then creating awareness through like meetings, conferences, speaking to people in various institutions, and advocacy. So and one of the things which came up, which I'll talk about later in the presentations, about the acceptance of open hardware. A lot of people have like issues and concerns about like switching to open hardware, and so advocacy is also one of the things that we want to work on to encourage people to adopt open hardware, and then also the community aspect of making sure there's a community to support and encourage people who want to adopt open hardware. So the workshop was a 2-week workshop. We we had a very short time after the grant was awarded, because the best time to have the workshop was during the vacation, when the faculty and graduate students would be free to attend. And there was I had about 3 weeks from when the grants were announced to sort of put the workshop together. So it was a really tight schedule, but it was a 2-week workshop. The target group was graduate students and faculty, and we had it at the University of Health and Allied Sciences in Ghana. And although we had about 25 teams applying, and we asked for group applications. So a team comprised like 3 people from close institutions, so that afterwards they could work together. And so we had 25 team applications in all, and we were able to accept 6 teams from 5 institutions. And the plan was to have only teams from Ghana, but we had 1 team from Ivory Coast which applied, and they had a really great application. So we had 1 team from Ivory Coast and 5 teams from Ghana taking part in the workshop. And we had the first 3 days. So the structure of this workshop was a bit different. I modeled it after the trend workshop, which I attended in 2017. But because the people that we're having were people who had very little experience with anything electronics or Arduino, so we needed to give a bit of introduction. And so the first 3 days was like a crash course, as much as possible, bring them up to speed in basic electronics, a bit of Arduino, Tinkercad for 3D modeling, and GitHub for documentation. And we had a couple of talks as well on like the open science hardware communities, Africa, Osh, Gosh. And so it was a really like a crash course the first 3 days, just to sort of give a breath of all the things that they needed. And myself, and we had 4 other facilitators, sorry. 3 of them, Charles, Jonathan, and Adelaide, are taking part in the trend workshop with me in Cape Town, and they are faculty at the university. So they joined me, and Harry as well from the Kumasi Hive came to help out. And then along the way, we also had a live call with Andre to speak to the participants. So, like I said, because we had a lot of people who had no idea, and we couldn't. I thought it wouldn't be really feasible to ask them to apply with projects they had in mind to build. And so what we did was, based on the FOSH demand survey that Andrea had conducted earlier, and then looking at the local context, we selected 6 equipment, and we basically we got the tools and the materials needed to build those equipment based on the bill of materials from the projects. And then when the students came in, we assigned them to the various projects to match as much as possible their interest. So the students didn't come with their own project. We had the project selected already, and they basically just came to learn how to build the equipment. Okay, so those are the 6 projects that we had. And so after the first 3 days of the introductory lectures, they just basically went into building. So we asked them to research about the project, since some of them were not very familiar with them, but then to read about them, how they worked, how the open projects that were online, I mean, the kinds of materials needed and that sort of thing. And then we basically left them on their own. Initially, I was very concerned that they may not be able to pick up, but after the first day or 2, we realized that the students started owning the projects. They were researching, they were reading, they were finding out how to build stuff. And all we did was to facilitate. So in case they had questions about specific things or needed specific support, the facilitators were there to help them out. But they basically owned the projects, and they were researching and trying to learn how to replicate what the projects online had already. And then, so that was over the 8 days. when they were building. And on the very last day, we had a conference. So we invited members of the university community, students and faculty, and administrators, university administrators as well, to come together. So we had this conference where myself and Jonathan spoke about open science generally and open Labware, and the merits of switching to, open hardware, especially in our context where lab equipment is one of the barriers to research. And we also had the teams, so all the teams exhibited the equipment that they had built at the conference as well. So that was on the last day. So in terms of outcomes, we had 18 faculty and students trained. There were 70 participants in all at the conference that we had on the last day. And there were 6 equipments that the students worked on. Some of the things that came up, I'm still not done. We made the students fill some surveys during the workshop, but I'm not yet done putting the data together. But from qualitatively, some of the things that really came up in terms of challenges to the adoption of open Labware were lack of institutional support, lack of access to tools for building, like the 3D printers, on-site technical support. So after leaving the workshop, getting support to continue building, and then problems in terms of calibration. So one of the things that some of the participants, especially at the conference, are asking, how can you be sure that the data you're getting from your open Labware is verifiable, is standard, that sort of thing. And then finally, funding to purchase the hardware, to purchase the components and the tools that are needed to build their own equipment. And then in terms of recommendations from the participants, most of them were talking about another workshop, because this was like an introductory workshop and you had to learn so much and try to build. And they recommended an advanced workshop for the teams to deepen their expertise and to actually build the equipment that they needed, and further training opportunities as well, and dedicated facilitators. So we plan to have one facilitator for each team, but unfortunately that fell through. It didn't go through. So we didn't have, we had about 4 facilitators for 6 teams in all, but they felt if we had a dedicated facilitator for each team, that would help more. And then the duration. So almost everyone was unanimous about the duration, that the 2 weeks was not enough to cover the material. And to be able to build the equipment as well. And in terms of the next steps, I'm working on a project website. So some of the things, few how-to guides to get people started, and maybe I'm sure some things are already online. So I'll probably just have to curate the resources, how to setting up an Arduino and stuff like that. And then links to local hardware stores. So some of the participants were, I tried as much as possible to source the components from local hardware stores. It was only the 3D printer, I think, which had to be imported. And so they were surprised there were stores in Ghana where you could actually buy stuff like resistors and capacitors and Arduinos. And so links to local hardware stores so people can actually know where to buy the equipment when they need them. And then also maker spaces. So a lot of people didn't know places like the Commerce Hive, and then in Accra, the Impact Hub have tools like 3D printers and laser cutters that people can use to build. And so to put that together on the website, and going forward for the community, with the people who came to take part in the workshop, and beyond, getting a database so people know who to speak to in case they need help and assistance with maybe writing code or designing something. And then also highlighting the success stories. So I think that will encourage people as well. If they know that people in similar circumstances have been able to build their own equipment, then that would be a motivation for other scientists to think about building their own equipment. And then beyond that, I think some of the things that we need to work on is supporting the teams to build their own equipment. So, like I said, this was an introductory workshop, and so we selected the equipment, and they just basically came to learn how to build them. But then to support the teams remotely so they can build their own equipment, and advocating for open hardware at the universities and like the scientific um, societies in Ghana, so people get to know about open hardware and know it's like a viable option to replace equipment that may be faulty or damaged. And I'm also thinking about clubs for graduate students. So I realized that graduate students are usually the ones who are very enthusiastic about it because um, well, they do most of the research in the universities, and they are the ones who are burdened with not having the equipment to conduct their research. And I mean, they have more time compared to faculty to build and get interested in stuff like that. So we're also looking at possibly having like clubs where graduate students can learn and about open hardware and how to build their own equipment. So, well, in terms of in concluding, I'd say there's a great potential for open labware in academia in Ghana, and probably not just in Ghana, but in other limited resource settings to improve teaching and research. And some of the challenges are like low awareness. People just don't know that it's possible. And then the skills to be able to build the equipment once they know that it's possible, and also institutional support. So in the structures to support open hardware from the top in terms of administration is not really there. And there are also opportunities for like hardware companies to sell low-cost science equipment because a few of some of the participants were like, I mean, it's interesting to learn about this and to know you can build, but then they will not have the time because of like the teaching load, etc. So, I mean, if it's possible to have companies building these equipment at a cheaper price, like that like meet a need because they need the equipment, but the price of like proprietary ones are so expensive. So if there are companies that are building low cost open labware, there's also a need for companies like that. So how like anyone else can get involved? Remotely mentoring the teams that want to build their own equipment. So some of the teams have expressed interest in building their own equipment now, and so like if you have people be interested in mentoring the teams remotely to build their own equipment, and also developing like a standard curriculum for the training workshops. So I think a lot of training workshops are coming up now, but if we can develop like a standard curriculum, and I'm really excited about the Mozilla Open leaders hardware track now. I mean, I'm sure when that is through, we'll have like a standard curriculum that can be used in terms of training for people who want to get involved in open labware, and setting up a project website with resources that are will suit the context here, and then advocating to encourage the university administrators to support open hardware and also securing funding for the project activity. Yes, so that's my presentation. Thank you very much. And if there are any questions.